Hello developers, let's start developing. So if you like this kind of content, don't forget to mash those buttons, click like, subscribe, comment and whatever. And we're gonna be taking on the 11th day of Advent of Code. Since this is a shortened year, we will have this is the penultimate task. What we have is a network. And inside the network we are you, which means that we need to find the shortest, not the shortest, but all the paths going from U to out. So this means that AAA is connected to U and HHH, U is connected to BBB and CCC. I'm gonna use the single letter variables. B is connected to D and E, C is connected to D and E and F. And now going from U to out, that is the only thing that interests us. And actually, there is quite an easy way to figure this out. Since we're not gonna go through all of the options. Why? Because we don't need to. So let's just solve this demo value in Excel. We're not gonna solve everything in Excel. We're just gonna solve some of them. So let's say we have AAA, we have U, we have BBB, CCC, DDD, EEE, FFF, GGG, HHH, III, and I think that's all, and we have out. So initially I'm gonna put a 0 at all of them. So how many ways can we start at U and get to them, to out? So for U it's an obvious 1. And then we go in and we process. So let's say we're gonna start our processing with U. So this is our stack, so to say. Let's call it red. So we're gonna process U. U has this. So we're gonna add 1, add the U value to BBB and C, to B and C. And we're gonna mark them that we need to process them, and we're gonna take away U. So now we're gonna start this thing over again. So we're gonna process B now. That's this one, which means we're gonna add the B value to D and to E. And we're gonna mark that D and E should be processed. This is the top of our stack. So next on, we're gonna need to process C. That's this one. So we're gonna add the C value to D, so this becomes 2. We're gonna add the C value to E, this becomes 2, and we're gonna add the C value to F, which this becomes 1. And we're gonna add D to our Q. No, we're not, it's already there. We're not gonna add E to our Q, it's already there, and we're gonna add F to our Q. Next, we're gonna take on D actually, which only connects to G. So for G, we're gonna add the value that's already in D and enter it in our queue. Next, we're taking E, and E only connects to out. So we're gonna take the out value and add the E value. This is here. Since out is terminal, we don't care what happens after, we're not gonna add it. And anyway, it's not even here. So for F also connects to out, so this is 1, we're gonna add it, so this becomes 3. We're taking out F, and G connects to out as well. We're gonna take those and add them here, and our stack is empty, we are done, and we have our solution of 5. Now, the only thing that's left is we need to actually implement this in code. So this is our input. I think this is exactly the GraphViz format, but anyway, we're gonna need to have some kind of node, let's say, which is gonna have a name, which is a string, and connections, which is a string array. So this is our input type. We might get some other types later on, but this is just to store whatever we take out from the lines. So once more, we can use a regex here, but let's not do that. We're gonna take our line and let's see how we end up with a node. Yeah, we can just set the return type to not a string array, this is going to be a node array. It replaced it everywhere, even where it wasn't supposed to. So we need to process our input now. So for the line, we're going to split the line on the character, not that, but this. Actually, this space. On this. So on the one hand, we have the name, and the other one, we have a space-separated list of all its connections. So we're gonna separate that into a head and a tail, let's call it, or a name and a tail. And connections is we're gonna split the tail on a space. We're returning the name and the connections, and that is a node array. So this says that we're returning an array of, yeah, it's not going to detect that that is a node. For that we would have to say, yes, return a node array. And it's not going to complain. So how do we do this? So first of all, I will reformat the input. I will actually, this is just for reading the input. The input is, I think, read OK. Of course, never trust a developer when they say they did something. We have tools to check it. Start debug 11. Let's see the actual input. Looks okay. So it seems that our reading of the input is fine. So first of all, I'm gonna transfer this around on its head. I will actually have nodes which are a record, a string of a string and a string array. And do something, but only I will use a for of loop. For each node of the input, use exactly that. The nodes of node name is node connections. And we can even console log the nodes to see what kind of structure did I make here. So I transferred that type of input into this type of a structure. So this is much more straightforward because now I can define the start, for example. Now I will define a queue, a string array, and initially I'm gonna put u in there. And now I will just loop. While the length of the queue is not empty, take out, yeah, I will do a let here because I might want to do some things to it. No. Yeah, let's have it as a constant queue. So we're gonna take out the first, pop out the first element and take out its connections. Actually, I will also make another record which will have the strings and the weights. So I will have an object like this. I can use the same object, but in this case I want to use another one. Or do I? Yeah, let's use another one. Paths, which will be a record. of a string and a number. So now I will say paths of node name is 0 because that's the initial value. But I will also say that paths of u is 1 because there is one way to get to u. We get to u. That's it. That's our starting point. So we're getting our connections, and now we needed to do two things. For each of those connections, we need to add the u number. So first of all, by the definition, this task won't have any cycles inside of it. Because if there is a cycle, then the answer is always going to be infinity. If there is a cycle that we need to go through, we can go through that cycle once or twice or thrice, or we can go infinite amount of times. Yeah, that kind of means that if you have a roundabout on your way to work, that means that your path to your work is kind of infinite, but don't use that as an excuse if you're running late. Oh, boss, my path was infinite. So, which means that we're gonna make a tree out of our network, kinda, sorta, and we can, use this kind of approach. So we're gonna take the connections, we're gonna need to take the path count, that's that, and for each of the connections, we're not gonna do this, we're gonna do something similar. We're just gonna say for each of the connections, paths of connection, we're gonna add the current path count to that. Seems about right. And if this thing is not already in the queue, add it to the queue. It could be that much. Let's see. So at the end we need just to return paths of out. I'm gonna add a quick debug here. If we're debugging, run the queue, run the paths, and actually give me the current one. Do we need the queue? I don't think so. Just leave me the current one. Let's see what happens. So, we processed U, we processed B, we processed C, D. Did we go in that order? U, B, C, D, E, F, G, and then out. But once we processed out, our code broke because out is not in the list of nodes. So for each path of con is path count, and connections is nodes of out. We needed to process out. So how do we do that? Well, if not connections, continue. So if we get to a node that doesn't have any other connections, there might be a dead end somewhere. We just, ignore it. That's not on a possible path. So let's see what we get now. We got the result. Part 1 is not a number. We might want to see the path's value. Let's check it out. So now U is 1, B and C became 1, B and C and D and E became 1 when we processed, and then after we processed C, actually I'm writing them the wrong way around. It should be like this, so it's going to be easier to see. So we're starting with this, and the current is U. processed B and C. Processing B, D and E get 1. Processing C, D, E, F get 1. Processing D, G gets 2. Processing E, out should get 2. But out got not a number. Now we're processing E actually, and E is a 2, and E is connected to out. Why is that different? Oh, because over here we don't have a paths of out, and we kind of want that. We're gonna add it initially because we manage only to add everything that has an input. Yeah, and over here we're doing our continue before that, so yeah, we don't really care if we get some, the other dead ends will also get a none, but we don't really care about that. Yeah, so let's remove this. Let's try on the huge input, which has much more connections. I didn't even try to visualize it. This is gonna be complicated. And note that in this way, we're gonna process each element. We might process it twice. What happens if we have made a network like this? You are connected to BBB and to B and C. B is connected to out, and C is connected to B and to out. Yeah. Now we would process, yeah, this, how the stack would look like. So we're gonna process U, then we're gonna process B and C. When we're processing B, we're gonna remove U, we're gonna remove B. When we're processing B, when we process C, we're gonna put B again. And let's see how that thing will go out, because there are two ways now to get to out. You can go UB out or UCB out. So U has 1, this became 1 as well. When we're processing B, this becomes 1. When we're processing C, this becomes 2. This becomes 2. And then when we process B, this becomes 4. This is a bug. Because we have U to B to out, we have U to C to out, and we have U to B to C to out. U to C to B to out. Oh. Let's try our code actually on this input. We should get the value. I have no idea what we'll get, but the correct answer is 3. And yes, our algorithm gave us 4. Yeah, we have a problem. How do we solve this? Let's have two numbers here instead. Initially, yeah, everything is zeroed out. So now we're putting U on the Q. We're taking it out. We're putting 1 in B and C. We're adding B and C on the Q. When we're processing B, got it. We're putting, this is gonna be like this. When we're processing B, we put this value here. And we increase we copy this value here. When we process C, we add this value here, we add this value here, and then we put in B on the queue because we need to process it again. So when we process B the second time around, we add the difference of these two numbers because one is already accounted for. So we're gonna get 3. Let's try to implement this. I'm not sure if this will work. So paths is not a record of numbers, it's a pair of numbers. So it's gonna be 0, 0 for everything except for u, which will be 1, 0 initially. We're gonna update it to 1, and out has, well, 0, 0 because we don't care about the second 0. We can actually put a none here if we want, because we're not leaving the out. Let's see where we have issues. So over here at the very end, we're gonna say copy over, not path count. Yeah, we're gonna say path count. Yeah, paths of current is actually gonna be the path count dot 0 of 0, and once more path count of 0. So we're copying that. That is the last value that we actually had. We're not gonna call this path count. So the first one is path count, the other is old value. We don't care about that. We don't care about, yeah, we care about the old value, ref count. So we have the path count and ref count, and at the very end we're setting it to path count, path count. So instead of adding the path count, we're adding the path count minus the previous count. Yeah, only we're setting this on the first value. We're not touching the second value. The second value only gets touched when we are running it through the queue. It might work. One way to find out. The result part 1 is 3, comma, not a number. Great. We got 3 paths. And let's see, just not paths dot of out, but actually we can write this like this since we know the name. Paths of out, the first element. The second one is always going to be not a number. So the result is 3. For this, let's hope that it's also 5 for this, that we didn't broke anything. In this case, we're always gonna, I don't think that we did, because this will always be 0. We're not visiting anything twice. Actually, let's see if that is the case. Yeah, I'm quite sure that in this pathological example, the order is gonna be U, B, C, B. U, B, C, out, B, out. Yeah, we're also processing out, but that's not much of a processing. So B is processed twice. In this case, everything is processed exactly once. Yeah, and we're getting 5. So, the moment of truth. Let's try it on this huge monstrosity. We have 575 different nodes, and I'm guessing out is not one of them. Yeah, so 576 at the very least. What does you do? Yeah, you initially connects to a lot of this. So we're gonna get a huge number. If we try to go through all of the paths, we're gonna spend a lot of time processing. So yeah, it's 791, maybe. I have no idea whether we have duplicates in this, but we can find out if we really want to. Let's see if this is the correct value, and let's see if we have the right answer. Great. Let's continue on to part 2. I will read about it a bit and I'll be back. Seems like an interesting problem, and this is something that Advent of Code loves doing. We are taking a known problem because, to be honest, I didn't invent the algorithm that I just show you. That's a very widely known algorithm of counting the paths through a network. But I just, yeah, this is an original implementation, but yeah. But they love to take a known algorithm and then add a bit of requirement that in a real world doesn't mean too much, but it completely throws off the performance of the algorithm. I think that in this case I should be able to implement a nice solution. So, but for this we're not going with you or me. We want to find all the paths from the server rack SVR to out. But we need to count only the paths that go through the FFT and the DAC. FFT is fast Fourier transform, the DAC is digital to analog converter. That's why it's not a DAS or something like that, it's DAC, it's C from converter. So we need to find out. So yeah, we have 1, 2, 3, 4, 5, 6, 7, 8 paths in this network that go through from SVR to out, but only these two actually visit both of them. It is mentioned that it doesn't matter the order in which we visit them, but let's leave that for a second part for now. Don't forget to mash the buttons and keep developing.